part of the review is when, ladies and gentlemen, when you get onto Edmodo, let me go home so I can kind of show you. You're going to log on, and I'm not sure what yours looks like, but this is what mine looks like, okay? In your Algebra 1 class, you guys have a folder, okay? It's called EOC Review Materials. So when you get onto Edmodo and log on, you're going to click on this file. Now, all of our review sessions are going to pop up once I get them loaded in, okay? Any materials that I pass out to you that I happen to upload as a PDF document, you can have access to. The main thing is rewatching the videos, the PDF files of the notes that we do in class. And I also put up extra review videos. This link right here will take you to a Weebly website where she recorded videos for a lot of the main readiness standards that you guys are going to be tested on. So this is really important if you can get on there to watch those videos. They're really, really helpful. Okay, I had my tutorial kids watching them yesterday after school, and they really liked watching them a lot. Okay, this Algebra 1 EOC practice, it's from North Carolina. There are some stuff not in it that you'll be tested on, but I will cover those, and you will get materials on those for practice questions. This is the packet that I was talking about, that 40-page packet that I was passing out for my tutorial kids. If you decide you want to look at this, okay, instead of having to print it off, you can open up the PDF file and work the practice problems yourself, okay? And if you want an actual copy, please see me individually, and I will put your name on the, I'll put your name on the list and I'll make a copy. There are 5 main objectives that are going to be covered on your Algebra EOC. Objectives is basically a blanket term for little chunks or families of targeted learning techniques that I've taught you guys over the year, okay? So functional relationships for Objective 1, for example, covers all kinds of stuff. It covers domain and range, independent, dependent, being able to describe a linear equation of function notation. Okay, so functional relationships. Being able to take multiple representations and determine if the equation that you're given represents a functional or a functional relationship, basically. Okay. Okay, one of the main things I want to tell you guys is that when we get down to Objective 2 and Objective 3, those are the main 2 objectives that have the most tested questions. Does that make sense? Objective 2 had approximately 12 tested questions. Objective 3 had approximately 15 tested questions on the EOC. So when we cover Objective 2 and Objective 3, you guys, I highly recommend going back and reviewing those 2 main objectives, okay? Our first objective is functional relationships. Before I get into functional relationships, we need to identify a linear function in the form of y equals mx plus d. What does b stand for? This is our y-intercept. It's also our constant, okay? So if you were given a problem and it said an initial charge of something, that's always going to be your constant. What does the m represent? This is your slope, or your rate of change, okay? Do I need to know what x is? What is x? It's a variable. What type of variable? Starts with an I.
Independent.
Independent.
What?
Okay, so we're going to be talking about independent, dependent. What is y? If x is independent, y is dependent. Okay? So when I talk about linear functions, we need to be able to identify the slope and the y-intercept in our problems. Okay? All right, so let's take a look at this. It's written out for you a little bit. Please stop the extra chatter. If I'm given a graph, my independent variable is going to lie on the x-axis. Okay? Those are all of our x values. Our dependent variable is going to lie on the y-axis. Okay? If I'm given a table of values, our independent variable is our input, the dependent variable is our output. If I'm given an equation, our independent variable is that x right here. Okay? Our dependent variable is y, otherwise known as g of x or f of x. Okay? It could be written in function formation, okay, or function notation. That's what I meant to say. No, it's just a letter that stands for a function of x. You could do h of x if you wanted to. Okay, here's another example of an equation not necessarily written in the form of y equals 24x. Sometimes you can have distance and time, for example, okay? Your distance is dependent on the time. Does that make sense?
Yes.
Okay. So let's take a look at this. Let's try to match some of this as a class. What does it mean? Independent variable. Take a look at these words. Which one of these can I select to put into our independent variable column?
Domain.
Domain. Somebody said before.
I did input.
X value.
Cause. X values.
Wait, how come those didn't do it? Those did.
I don't know. Domain, if I have a domain, the other one is going to be
Range.
Range is our dependent variable. Before is after. Cause,
Effect.
X values, Y values, input, output. Okay. Let's get this one. Okay, here's something important. Some of you are getting this wrong. Shh. Table over here should stop. A function is a relation where each value from the first set, the domain, is mapped to exactly one value in the second set, the range. Okay? That means I cannot have repeating what values? My x values cannot repeat. Okay. Hold on a second. Okay, so let's look at the next slide. Let's take a look at these table of values and determine which relations are functions. Is this a function?
Yes.
Why?
Yes.
What about this one?
No.
No, what's repeating?
One.
Notice we're looking at the X column, okay? What about this one?
Yes.
Yes. I can have repeating Y values. It is still a function. Okay, what about this one? Is this a function?
Yes.
Yes. What about this one?
Yes.
Yes. Okay, good job. All right, mapping. A mapping is another representation in determining whether or not the relationship is a function, okay? Okay, but mapping is a way to represent a function, which means one of my x values have to be mapped to my y values, which means we take a line, we draw it from one number to the next, okay? Okay, does this mapping represent a function?
Yes.
Yes, each x value is mapped to one y value, okay? That is a function. What about this one?
No.
Why?
Negative 3.
-3 goes to two different... Nope, that's not it. What about this one?
Yes.
Yes. Okay. Another way to determine if you're looking at a graph is to perform the vertical line test. If I can draw a vertical line at any point in my graph, and it does not touch more than one point, then it is a function. If I draw a vertical line, and it passes through more than one point, it is not a function. Can I do the vertical line test here?
Yes. Yes.
Okay, if I draw a line through points, is this one going through more than one point? It is not a function. What about this one?
No.
It is not a function. It's passing through way too many points. What about this one?
No.
No, it's passing through more than 1 point. It's touching my graph more than once. Okay. What about this one?
No.
Okay, it's passing through more than once. What about this one?
No.
Yes. Okay. What about this one?
Yes.
Yes, I can draw a line through each point and it's not going to pass through more than one. Okay. Okay, identify the domain and range of each function. What is my domain again?
X.
My x values. 1,
No.
6, 9, 10, 1.
It's not a function.
What are my range values?
-3, -2, -1, 0, 3.
What about this one?
0.
Domain is 0, 3, 5, 6, 7. What about the range?
-2, 5, 3, 9, 0.
Domain?
2, 1, 0. -1, -2.
What about range?
12, 5, 0, -3, -4.
Excellent. Okay, in your notebooks, I want you guys to tell me, given the domain, here's your function right here. It happens to be quadratic. What is the range for the specific domains indicated? How do I find the range if I'm given the set of the domain values?
Plug it in.
Y equals 0 squared minus 7.
-7.
Y equals, what about this? What about the second one?
Y equals 3.
25
Y
minus
squared.
18.
25 minus 7 is? Okay. And last one.
Oh gosh.
11.
121. That's 121.
What's 121 minus 7?
It's 114.
Okay. You guys do this one and this one in your notes.
Can we plug it into the same one?
Yes. Okay, for number 2, if I'm given the domain of -1, 1, and 4, I'm going to plug this into my equation for all of my x values. So y equals -1 squared minus 7. Okay, keep in mind when you guys are plugging these values in for x, you need to put it in parentheses because if I have a negative and I square a negative in parentheses, it's going to be different when I square it out of parentheses, okay? So basically I have -1 times -1, which gives me what?
6, -6.
A positive 1.
Yeah.
Positive 1 minus 7 is -6, okay? Now if I plug 1 in, what do I get? 1 squared minus 7 is the same thing, right? -6. Let's plug the last number in. 4 squared minus 7. What's 16 minus 7? 9. So my range is -6, -6, and 9. Okay? Right, let's do this one. I'm going to do the first couple values, and that's it. I think we get the point. -5 squared minus 7. -5 times -5 is what?
25.
Positive 25. 25 minus 7 gives you? 18. Let's plug in -4. We already got all that. We did that over here. -4 times -4 is a positive 16. 16 minus 7 is 9. Okay? Moving on. A powerful way to write y. Please stop talking. A powerful way to write y tells you that y depends on x. Okay? So if I have y equals 3x minus 4, we can also write it in function notation as f of x equals 3x minus 4. Okay? This means a function of x. And every time we have anything in parentheses, we use the word of. Okay? It's just a function of x. It's just basically telling us it's a function. So given f of x equals 3x minus 4, here's what we're going to do. We're going to evaluate given a value for x. So if I see this as f of 5 equals 11, anywhere I see x, I'm going to put in 5, okay? This is basically telling me that when x is 5, y is 11, okay? So here's what happened. They said f of 5 equals 3 times 5 minus 4. 3 times 5 is 15. 15 minus 4 is 11. Okay? Now, going the other way. If I say f of x equals 5, it is the same as saying y equals 5. So if y equals 5, what is x? We're basically plugging 5 in for y and solving. Okay? You're going to add 4 on both sides. Evelyn, you're going to go pick that up.
Wait, how'd you get 3? How'd you get 3 in before?
You're going to divide by 3 on both sides. What?
Where'd you get the 3x minus 4? Oh, okay.
9 divided by 3 is 3. So 3 equals x. Okay? Alright. Okay, so here's what I want you guys to do in your notes. If b of x equals 6x minus 8, what is b of 5? What do I have to do here?
Plug in 5.
Plug in 5 for all of the x's that I see. I only see one x here. Okay? What do I do here? Plug it in for t. Now, don't forget, it needs to be in parentheses. You guys do it. Okay, what do we get when we plug 5 in for x?
22. 20. Okay.
6 times 5 minus 8. 6 times 5 is 30. What's 30 minus 8?
22.
Good. What about this one? I've got 4 times negative 3 squared minus 3. What do I do first?
You use negative 3 squared.
What is negative 3 times negative 3?
Negative 9 squared.
Positive 9.
Positive 9.
What's 4 times 9?
36.
36 minus 3?
33.
Bam. Okay? That's not so hard. Which graph best models the relationship? I have 0, 2, 2, 4, 6. Just because it's a relationship doesn't mean it's a function, okay? This happens to not be a function because 2 is repeating. So here I'm going to look at which one of my values gives me repeating 2's. Okay, well here's a dot, dot. Here we go.
Hey.
I'm seeing like little.
You forgot the one on the 0 for C.
Yeah.
Okay, which one?
For C9. Brady, I don't think he'll go.
Which mapping
look up that
diagram best
past
represents the function? F of x equals negative 2x squared minus 2 when the domain of the function is negative 2, 0, and 1. Domain means what? X values, which means I need to plug these values in for x. So if I have negative 2 times negative 2 squared minus 2, negative 2 squared is just 4. Negative 2 times 4 is negative 8. Negative 8 minus 2 is negative 10. Which one of my y values do I have that's negative 10 in these answer choices? C or D, which means I can cross off A and B automatically. Okay, McKay? All right, let's do 0. If I have negative 2 times 0 squared minus 2, anything times 0 is 0, which means I have negative 2. Now, please pay attention that if I have negative 2, it has to map to negative 10. My negative 2 maps to negative 10, negative 2 maps to negative 10. If I have 0, it has to map to negative 2. Does 0 map to negative 2 here? No. So what's our answer? There you go. Okay. The relation given by the ordered pairs, these are your ordered pairs. It can be represented in several ways, which means I have multiple representations. When I have multiple representations, I have a table of values. I have a mapping diagram, okay? I'm given an equation right here, and I'm given a graph. So you'll get a question on the test which will tell you multiple representations. You've done this before, okay? Which one of these is not a correct representation? 3. Why is it 3?
Because 12 is going to 2 different ones.
Yeah, 12 is mapped to 2 y values. Okay, that's not shown here. So that means we can cross off A and C. Make sure you do your process of elimination. Is it 3 only?
No, it's
Yay.
D also.
Why is it this one? If you match the ordered pairs, 12 and 89 cents, is this 89 cents?
No.
Yes.
Yes.
What about 16.99 cents? Is this 99 cents or is it more than $1?
More than $1.
Yes, I was
Your
right.
answer choice is gonna be-
I know all like
Okay. Which of the following tables does not represent a function?
C.
Why is it C?
2 negative 2.
There you go. All right. Here's what I want you guys to do. You have practice problems. You have until the end of class to finish the problems. What you don't finish in class today needs to be finished and brought back tomorrow so we can go over the answers. This video will be on Edmodo. So